start coding a Centipede game. And when we get done, it'll look something like this. We'll have a player, a Centipede, and we'll have some bullets, and we'll keep score and things like that. For today, for part one, all we want to do is set up our player character, which will look like this. So when we're done, we'll be able to control this character with the keyboard, and we'll have our canvas set up and go from there. For now, this is what we have. So let me show you how I arrived at that, and then we'll start to create a canvas and get our character onto the canvas. I'm going to be working in Visual Studio Code, but you can use any HTML editor. We've been using in class Code.js or Glitch. Those work great. But regardless, find a place where you can type this code in. Now, some of the code I've already written out. It's standard code that we use for many of our games, and some of it we'll be typing on the fly here. So this is our index.html file, and it has all the usual things that we include in our programs. I've put a note in here as a comment letting you know that I'm basing this game off of a game that a gentleman made on Khan Academy, Shad Sluter, and he actually had a great set of videos that went along with his game, but they've been taken down off YouTube. After many years, I used those in class, so I'm going to set my own up. We're not going to code this in Khan Academy. As I said, we're going to do it right as an HTML application with JavaScript. We will use p5.js, and you can see that I've attached that p5.min.js file here, along with the two files that we are going to write, a game.js and a player.js. We also have a style sheet. We won't have much code in there, at least not to start, but we will have a style sheet as well. So we'll have 4 files that we're creating. Index you can see here, which I'll give you a copy of. And then let's take a look at our style sheet, which isn't much. I simply set the background of the body to gray. I use 90, 90, 90, and that is why we have this gray background here. Okay, so let's start talking about our game. The first thing that we want to do is we want to build a canvas. So what I've done is ahead of time I've sort of set up with some comments the areas of the game.js file that we're going to create. If we have any game constants, I will define those starting at line 4. We will have global variables, and those will be defined starting at line 8, although those lines are going to shift. We'll have to set up our canvas with our P5 code. We are making a game, so we're going to have scenes. So I'm going to start right out by implementing our scenes. I will code those as functions here under scene definitions. Our animation loop is going to be our draw function, and it's just going to include that switch that we use to go between scenes. And then finally, we'll have some keyboard event handlers so we can steer our player. Okay, so let's just get a few things going here. Let's start by setting up our canvas. And I'll do that right here. We need a setup function, so function setup. And I've discovered that if I limit the width of this game to 700, it seems to play a little better. You make it too wide and it gets a little too difficult. We can adjust this later as we see fit, but let's start with this. It's going to yell at me because it doesn't know what game width is yet, but we'll define that here in a second. I'm just setting game width basically as a constraint to 700. This is one way to do it with an if statement. It's not the only way. Now, since I've introduced that variable game width, I better go up and define that. And let's define game height as well. So we're going to make this a global variable. We'll call it game width. And one way to go and grab that width is simply to take the window object from the DOM, from the document object model, window.innerWidth. I can't talk and type at the same time. Here's innerWidth. I'm going to subtract off 20 to give this a little bit of a border. And actually, I decided I wasn't going to use semicolons in this particular video. So let me get rid of that one I put on 700, and I won't include one here. I'm old school, and so I always used to use semicolons, but I'm trying to shift to more modern JavaScript using let and const when I can, and also only using semicolons when I have to. We'll see how that goes. So here's our inner height minus 20. So what we've done is we've made two variables, game width and game height. Those are the variables that we're going to use to create our canvas. Now I want to center our canvas using JavaScript, so I'm going to store my canvas in a CNV variable that I just invented, which means I need to have that variable defined globally here. So we'll go ahead and do that. CNV is going to be the output of create canvas. And we'll use game width and game height as our width and height of our canvas. Come on, baby. Makes the video longer when I keep making these typos. Okay. And right after I make the canvas, I do want to center that canvas, so I'm going to make a function called center canvas. Oops. Gotta be careful what I type there. Let me scroll this up a little so you can see it better. Center canvas, the only job of this is to simply center the canvas. And so basically what we're going to do is we'll create two variables, x and y. I'll just break this down into pieces so you can see what we're doing. I'm going to take the difference between the width of our canvas and the window width and divide it by 2. Put half it on the left and half it on the right. So that'll be the x coordinate. So window width minus width divided by 2. And we'll do the same thing with the window height. Okay, so I've got those two coordinates now. Now let's just position the canvas there. The canvas element has a method called position, and we can set the x and y coordinates. So I just created that function. I haven't called it yet. I want to call it right after I create the canvas, so I'm going to call it right here. And there's a few other things I'm going to set. I think I'll set that later. Let's set the text align for the entire application as center center. That'll help when we're displaying stuff on our canvas. And when we're playing this game, we're going to use a keyboard, at least for now. So I'm going to turn off the cursor. If we decide to use the mouse later, we can always turn it back on. Okay, and let's make a draw function here. Actually, let's make our first scene. No, let's just make a draw function. I'll take this out in a minute. So function draw, let's just set the background to black. And that way we can double check and make sure everything's working so far. I don't want to type too much before. Black is 0, 0, 0. So we'll just erase the canvas with a black, and we'll run that as our animation loop. We're going to put our switch in there later, but let me save this. Come over to my web browser. Let me do this. So there's our canvas. All right, I have it centered, and because my window is wider than 700 pixels, it's limited the width to 700. Okay, that's a good start. All right, now we need to invent a character that we can put on our canvas. So I'm going to make a global variable called player. And then in my player.js file, I'm actually going to define the properties of this object. You can see I already put some comments in just to save some typing. The constructor is going to go here. So that's just going to be function player with a capital P. Remember, our practice is to make our constructor functions begin with a capital letter. Our player needs to have an X and Y location. It needs a size, and it needs a speed. When we construct our original object, we're going to use those. All right, now I'm going to close this thing down here because I'm going to put code in for these other things. So as you can see, we're receiving parameters x, y, size, and speed. So those are going to be some of our properties. So I'm going to add those to the object. This dot x is going to be x. This dot y, oops, hit enter, man. This dot y is going to be y. This dot size, spell this correctly, is going to equal the size that they sent us. And this dot speed will be the speed. And we'll talk about these values in a minute here. But for now, just keep in mind that we're receiving these parameters. And so the first thing we're going to want to do is we want to make sure that our player can show itself. So I'm going to make a method called show. It doesn't receive any. And it's simply going to display the player on the screen. So let's turn the stroke off. I want this guy to be green. Obviously, you can change that. And there are two parts to my character. I decided to make it a little different than the original. The body is going to be a circle, but I also wanted to have a little gun sticking out of the top because the player shoots at the centipede. So the way I did that is I made a rect, and I said I'm going to start that just to the left of center, so this dot x minus 2, and I moved it up from the center, so this dot y, but I moved it up half of the diameter, and so that accomplishes that. But then I had to move it up an extra 5 pixels so that it starts high and draws into the shape. And then I made the width 4 and the height 6. And what that does is that puts a little, sorry about that. I don't want to reflect, I want to rect. This autocomplete's giving me the business. Not reg. All right, there we go. There's our rect. And then the ellipse is for the body. And the ellipse, we'll put it this dot x, this dot y, and then this dot size, because it's a circle. Let me scoot this up so you can see it a little bit. I got to add some lines to the bottom of this. Okay. This dot size and this dot size. Okay, so we've got a player and it'll draw itself. So let's make an instance of the player in our game setup, and then we'll see if we can get it to show up on the screen. Let's start with that. So right after we do the no cursor, let's make a player. We've already declared a variable player with a lowercase. It's going to be a new player object, so uppercase player. And let's see, where do we want this thing to show up? So let's do width over 2, halfway in the center of the canvas. Let's put it 3/4 of the way down the height. So I'm going to multiply by 0.75 times height. And then the size, I'm just going to make it 20 now, but we might want to add a variable later to keep track of that. And then the speed for now is going to start at 1. So our player just moves 1 pixel at a time. Okay, and now in our draw function, this is temporary, but let's just do player.show. See if we can get this sucker on the screen. Okay, so I have to save all these files if I haven't already. I think I have. Let's go back and look at the canvas and we'll refresh this thing. And we got some errors. So let me bring up my console. I happen to be working on my Mac, and I like that I can pop the console out as a separate screen here. Player line 18, so let's fix that. I'm going to make this a separate screen so we can do this. All right, so I need to go fix player line 18. Sorry about that. I got to pay better attention to my this dot show equals function. Yep. If you were watching this yelling at the screen, I apologize. There we go. We got this dot show equals function. Let's save that. Let's go back here and we'll refresh. And we got another error, so let's get that on. I supposed to spell player with lowercase in line 26. Let me get rid of that. Apologies for that as well. Did I use a lowercase b? Oh yeah, I did. I thought I typed uppercase. You probably were screaming at the computer for that too. All right, so let's save that. Come on, baby. Let's hope this is the last issue. All right. I don't see the dude. We've got one more error. Line 20. Oh gosh. The auto. We just want to fill. All right, I must have hit that. Okay, so let's, all right, here we go. Yes, okay, so we've got our character on the screen. Apologies for the typos. I got to get used to this autocomplete on Visual Studio, or just turn it off. Okay, so right now we have a character. It's not doing much. First of all, I think that's starting a little too high, but we'll worry about that later. What we want to do next is we want to start getting this thing to move. So let's make a function called this.move. And I have to make sure I type equals function. And in this.move, what we want to do is we want to deal with some keystroke events. So I'm going to go back to the game. We're going to handle the keys a little differently than we have in the past. I'm going to make a new global array called keys. And actually, it's just going to be more like a dictionary than an array. But keys is just going to keep track of whether a key has been pressed or released. So there's two events that we're going to deal with down here on our event handlers. The first one is key pressed. Oops. And remember, key pressed is part of our p5.js. That's not standard JavaScript. So when a key is pressed, I want to set the keys entry for whatever the key code happens to be to true. Okay, so my array is given a key code and the value is set to true. So if this happens to be the up arrow set to true. If it's the space bar set to true. Whatever key is pressed, it gets set to true. And similarly, we're going to do key release because we want to know when a key is released. So function key released. Let's make sure I spelled that right. And all we're going to do is set that particular key based on the key code to false. And keys is a global variable, a global object, and so we'll be able to access that from our player when we want to make it move. Now let's go into our player in our move function and let's deal with these keystrokes. So if the left arrow is pressed, so that would be keys, bracket left arrow. The constant in P5 for left arrow is left ARROW with an underscore. If that's true, then we want to move our player to the left. So that would be this dot x, and we want to subtract from its current location. So minus equals, and the amount we're going to subtract is this dot speed. Similarly, and I'm just going to start copying and pasting this. So then I want to do the same thing for right arrow. But I'm going to add that, right? When we move to the right, we add to our x location. Let's do the same thing for up arrow. And we're going to subtract from the y when we do that. And then for down arrow, we want to add to the y. So I got to make sure I change both of those. I need a y right here, and I need a plus equals right here. Okay. Now, let's put some constraints in. We want our player to stay on the screen, so let's make sure that we constrain this between we're going to constrain this dot x between 0 and width, and we're going to constrain this dot y I actually want to constrain this between 100 because I don't want it to be able to go higher than 100, and I'll show you why when we get to that, and the height. And actually, I tried this already and found out that it looks funny when he goes halfway off the screen, so I'm going to subtract this dot size divided by 2. And my guess is I probably need to do that with constraining x as well, but we may need to come back and deal with that later. I definitely know I needed to do it here. Okay. So this dot show, this dot move. Now that we have both of these, let's just make a container function called this dot update that I can just call to handle both of those at once. So we want to move and then show. And from the game, we just want to be able to say update, so we don't have to keep typing those twice. All right, so back here, instead of player.show, I'm going to do player.update. And let's see what that does for us. I'm crossing my fingers I don't get too many errors, since I had a bunch on the last round. Okay, oops, we got some errors. Player line 31. Come on, man. You probably already caught the constraint. Why did the and come in there? Okay. I got to pay attention to what I'm typing while I'm talking. All right, let's try this again. Another error. 42. This dot update equals function. Come on. I used to be good at this. Okay, there it is. Ooh, look at that. We're moving around. All right, we've basically accomplished what we wanted to accomplish in this video. There are a couple of little cleanup things that we're going to do, though. Remember, we're going to implement scenes in this game. And right now, we're working on a scene called the game playing scene. So I'm going to restructure my animation loop. I'm going to make a function called game playing scene, and basically all that code that we've put in the draw function so far is going to move up into the game playing scene function. So the functionality is there. What we want to do, since we're going to be using scenes, is we want to set up a switch so that our draw function decides which scene to be displaying depending on what's happening in the game. Okay, so I'm going to introduce a few new globals here. I need a variable called current scene. And I'm also going to set some constants so that we don't have to keep guessing what the numbers are. So I'm going to make a constant called playing game. I usually make my constants in all capitals. And I know this is eventually going to be scene 2, so I'm going to call that 2. And then for now, my current scene, since I only have one scene, is playing game. That's the one that we're going to set current scene to. And then when we want to change scenes, we just change the value of current scene. We've done that before in our other projects. So down here in draw, let's set up our switch. The switch is going to be focusing on the current scene. And then our first case is playing game. If we're playing the game, we want to call the game playing scene function. Oops, spell it right. Right now, that is the only case that we have for the switch. Eventually, we'll have a opening scene and a game over scene, and we can decide if we need any other scenes. But right now, we have one scene. I want to set this structure in place now, though, so as we work through the program and add more features, we don't have to move a boatload of code. Let's check this one more time and see if I didn't introduce any more errors. So there's my character. It's moving. There are no errors on my console. By the way, let's just try and move all the way up to the top here. And you'll notice it should stop at when I get to 100. Okay. And that's just because there's this other stuff going on up the top of the screen, and we don't want the character to be able to go up that high. I may constrain it a little lower than that. We'll see. And then let me show you at the bottom, the constraint down here. The fact that I moved it half a size up means it's going to sit there. Let's see what happens on this side. I probably need to fix that. Yeah, see, we don't want that. We don't want it to go halfway off the screen. So let's fix that right now, and then we'll call that a video. So we want to constrain, instead of at 0, we want to do this dot size over 2. So half of our size puts us so that we don't go past the edge on that side. And then width minus this dot size over 2. This should work. I kind of figured I needed that, but I didn't have it in my notes because I was probably rushing. All right, I save that. Let's refresh, and let's just try and drive this thing left and right. I'll go this way first. I should make the speed faster because it's going to take all day to get over there. Okay, so that works. And by the way I'm making this thing go diagonally is I'm holding down both the up and the left key, or the down and the left key. And that is possible because of the way we set up our, okay, so this works great. All right, the way we set up the keys. So let me just quickly go back and talk about that one more time. This block of if statements, I didn't use else because these can happen together. It's not an either or type of thing. So they can happen at the same time. So we just use a block of if statements. And in our game code, we simply set the value for that particular key to true when it's pressed, and we set it to false when it's released. So those are the keys, if you will, to getting the keyboard event handlers to work. I'm going to call this keyboard event handlers. Okay, so I do want to briefly just run through what we made so far. This is our first step in our Centipede program. We have our index file, and we've set up the usual elements in our header for a p5.js program. We called in the p5.js file, and we also brought in our player and game.js files. And we have our style sheet there. Speaking of the style sheet, remember there's not much there. It just shows the gray background for now. The main program for this game is called game.js. And today what we did was introduce a few global constants and variables. We set up the canvas, including centering the canvas. We created our first scene, which we're calling game playing scene. And the only thing it does right now is update our player with a and we put a black background on that. We have our draw loop, which just handles the displaying the scenes, and our event handlers that I just mentioned. The only object that we created so far is our player object. We made a constructor that receives 4 parameters. We set those as the properties of the player. And then we wrote out 3 methods. A move method that just kept track of if the keyboard was pressed, it would move our player. A show method that draws the player on the screen. And then just a combination, a method called update that we're using just to do move and show at the same time, so we don't have to keep typing those over and over again. Okay, that's it for now. And just to show you one more time, this is what we have. It's nothing fancy, but we've got the first step toward making a Centipede game here. And that's enough for this video. So good luck with getting the code working, and stay tuned for part 2.